What we see here to start with is the difference between rectangular coordinates, which is your XY coordinate plane, and your polar coordinates. In rectangular coordinates, we've always gone from the center, which is the origin, the point 0, 0. It is the same thing on polar, but we don't call it an XY point anymore. We call it the 0 pole, or pole 0, okay? Instead of having the X and Y axis, we now have the polar axis. So everything is like the unit circle. It starts off the positive X axis and goes counterclockwise. When I give you a point, it is no longer an X and a Y, but it is an R, which is a radius, and a theta, which is your angle. So where X's, we said that's your horizontal distance, and Y's was your vertical distance. Now your R is your distance out from the pole, and your theta is your angle at which you're looking around that pole. Okay? 1 point for us in polar can have many different polar coordinates. There's many different ways to represent this. Okay? So what you see down below here is similar to what we were talking about when we did angles for the first time. When we did angles for the first time, we said we start on the positive x-axis, which is what we're now calling our polar axis, and you go in a counterclockwise direction there when we are measuring our angles. There's that. Okay? So that's the beginning there. On the back, we are just going to practice graphing some polar points. So this is where we're starting today. So, again, you see the points differently, and you see the axes are different on the back page here. This is a circular axis. This is how we graph polar points. It has nothing to do anymore with my XY coordinate plane. Remember that when we do polar, we said the points are in the form R theta. So R is the distance out from the pole. Theta is the angle at which you are looking. So if I was to graph point A here, I'm going to walk you through this one to do this first, and then we'll do some on our own too. A is the point 3 pi over 3. The first thing you do, at least the first thing I do, it's almost like I read it backwards. I do the angle first and figure out where that is, and then go that distance along that angle. So for example, I would ask myself, where's pi over 3 here? Think about your unit circle. Where is that? Okay, it's 60 degrees. So these, see these axes here? These are all measuring by 30 degrees there, each of those lines. So this is 30 or pi over 6. This is pi over 3. This is pi over 2. The ones that are not included in here are the what? The pi over 4s. Where would the pi over 4s go? Directly into the corners there. Okay? So if I'm asked pi over 3, the first thing I identify is it's somewhere along that line. And I do identify that entire line because if it's positive, it goes out in a positive direction. If it's negative, it goes backwards. Okay? So in this case, if I'm asked to graph the point 3 pi over 3, I first identify this is pi over 3. And then from my polar center there, I go out 1, 2, 3. This would be my point A. So then B, the only difference between B and A is that my R in this one is what? Negative. So first I identify the angle. Where's pi over 6? It's this first one right here. But because my R is negative, that's why I have to think about pi over 6 being this entire thing. Instead of going out positive 4 towards that pi over 6, I go backwards 4. So that means when I graph point B, I'm going along that same line, but going backwards 4, which will end up point B being here. Questions on that? I know this is very different. That's why we take the time to just sit here and graph points at the beginning. All right, point C. C is the point 2, negative pi over 2. So first I've got to identify my angle. Where is negative pi over 2?
It's 3 pi over 2.
Okay, it's the same as 3 pi over 2, so down here. So I go to my angle there. This one says positive 2 in the negative pi over 2 direction. So where am I going to count from the middle? Down 2, right here. If your R is positive, you go in the exact direction that it tells you. If your R is negative, you go backwards from that. So point D, first I need to know where is 7 pi over 4. 7 pi over 4 is in what quadrant? Fourth. Okay, because we don't have that marked, you would have to understand that your 7 pi over 4 is about halfway right there. And then we want to go positive 3 in that direction. So that would be 1, 2, 3, right here. Take a minute and try to graph point E on your own. All right, real quick, check where your point E is. That's where mine landed. I circled it up there. Anyone need me to walk through that?
Yeah.
All right.
I went the other way.
Hang on.
Yes.
Okay, first thing you do is find the angle. When it says negative 5 pi over 6, which direction do I go?
Under.
Clockwise or counterclockwise?
Clockwise.
Clockwise. So negative 5 pi over 6 is backwards to this point.
Yeah. Cool.
All right, so here's my 5 pi over 6 line. If I would like to do a point in the positive direction, I go towards this part that I came to. But my point, my R value they gave me was what? Negative, so I go backwards along this line, 5. I know. Do you want me to give you some additional points to try? Yes? Okay, let's do one more. Do you want like negatives?
Yeah.
All right. Negative 4. Negative 4 pi over 3. Find your angle first, then go backwards from that because of the negative R. So first, I want to find where this point is. Where do I go first? Where's 2 pi over 3? Second quadrant right here. I've got positive 4, so that means I go along that exact line. Positive 4 is right there. Any issues with that point? All right, it says now, name point F 3 other ways where your angle is between negative 2 pi and 2 pi. All right, so that means, for example, we got to that point by going positive 2 pi over 3. How else could I get to that same angle? Negative, how many? 4 pi over 3. So this point would be exactly the same if I gave you this right here. Right? Negative 4 pi over 3 is going 4 pi over 3 backwards and going positive 4 in that direction. All right? How else could I identify that point? Because it says 3 other ways.
You go that way and do negative direction.
I could go the same angle, or not the same angle. I could go to the angle across from it and do the negative direction. What's the angle across from it right here? Huh? I could make that negative pi over 3 and go for my R backwards, which means I would have to make it what? Negative 4. Instead of negative pi over 3, I could make it 5 pi over 3 in the positive direction and also make it negative 4. Once you start like making you think about it like 15 different ways, you start to get the graphing a little bit better.
And then we're gonna like add X.
What's the difference between 2 and 3? It says name point F 2 other ways where what?
It can't be negative.
The angle is between 2 pi over 3 or 2 pi and 4 pi. That just means another full rotation. So if this was 2 pi over 3 right here, and I go another full rotation, what does it become? 8 pi over 3. Add 2 pi. So that's the same thing as 8 pi over 3. Which other one could I convert? I could convert this one as well. If I added 2 pi to that, add 2 pi to 5 pi over 3. 11 pi over 3 and negative 4. Okay. Take a minute. Try number 4 at the bottom. All right. Any issues placing point G?
No, I got that.
Backwards 3 pi over 4 and go out 2.5. All right. So if I'd like to name it other ways, someone give me one other way I could name G. 2.5 And what?
Pi over 4.
If I do pi over 4, that's the right direction, but what does your radius have to be?
Oh,
Negative. That's one way. Yes, ma'am. Any other ways people have found?
I know another way. I don't know how to say it.
Okay, so just explain to me where you're going on it then. Are you going clockwise or counterclockwise?
Clockwise.
Clockwise.
Wait.
Yeah.
Counterclockwise.
Counterclockwise. Okay. Counterclockwise to that is 5 pi over 4, and you're still going in the positive direction. That's one way to do it. Yes. How do I get to pi over 4 in a negative direction? Backwards how far? Backwards 7 pi over 4. Keep your radius negative. Okay? Now, the only other thing we are talking about today is how to switch between rectangular and polar points. There are formulas for this. They involve the formulas we talked about with vectors.
Yay.
I know. It's bringing it all back together here. All right, on the next page, this is where we're finishing up.
Alright, cool. This page?
Yep, a little bit. Not much. There are your two formulas for this.
Please stop.
If I would like to convert my polar points into rectangular points, I use these formulas. This is bringing a lot of things back together. We used these in this form for vectors. Like this.
I see.
We did that at one point in time for vectors. It gives you the x and the y. It's the same thing we're going to do here. So for something like number 5, I'm simply going to get my x point by doing negative 8 times the cosine of 5 pi over 3. My y point by doing negative 8 times the sine at 5 pi over 3. Honestly, this is why we end the year with polar, because it pulls together so many things. We did vectors, we've done cosine, sine, we've done graphing. What do you have to remember to figure this out? Your chart, everything. Okay? So remember your chart at the pi over 3 reference angle.
Oh, it's positive.
Okay, the cosine
Positive 1/2.
is positive 1/2, but we're in 5 pi over 3, which is what quadrant? Fourth. So that is still positive for cosine. So I'm getting the 1/2 out of my chart.
So can we use a chart for the activity?
Yes.
Like a blank chart?
I'll give you a blank one.
Oh.
But that just means one of the 4 of you has to know it.
Are you recording
That's
now?
you.
Yeah. I always do. Hello, Matthew.
Hi, recording.
All right. Second one. Sine at 5 pi over 3. Because we're in the 4th quadrant, it's going to be negative root 3 over 2. To get my final answer, I just multiply those together. What's that give me for my x? Negative 4.
Wow.
Yes. That cancels and makes it 4 root 3. Okay? I can do the same thing with number 6. To get my x and my y, I do 2 cosine at 3 pi over 2. 2 sine 3 pi over 2. If I go back through my chart, my cosine at 3 pi over 2 is 0. Sine at 3 pi over 2 is negative 1. Gives me negative 2. But if you graph these in polar and you graph the xy coordinate plane, they should lay on top of each other. They should be the exact same thing. Like, for example, this one. This is a good one to do for practice. If I was in my circular graph, I would find my angle. Where's 3 pi over 2? Straight down. Positive 2 in that direction. That would be my polar coordinate. Well, think about it. Where would I graph 0, negative 2? In my xy coordinate plane. The same place. So they should match up. If they don't, you have done either your calculations wrong or your graphing wrong. Pick one. Same type of thing for number 5. Let's review how to graph that in polar form. Where's the angle 5 pi over 3? 5 pi over 3 is in what quadrant? Fourth. It's right here. But because it's -8, I'm going to go where? Backwards 8. So that's going to be like up there somewhere? Well, think about this. -x, positive y should end up in the same type of place. Okay? If you do not have a radian that you have the answer from your chart like you would in number 7, you'd have to type it in your calculator. Okay? I'm going to deal with rectangular form to polar form on the back page next time. Everyone find the page that says polar coordinates worksheet. I'll be right there. This.
I'm excited.
We are going to do that page 1 through 16. We will come back next class and tackle the rest of it.
I say 1 through